Hello and welcome to this online lecture about valence shell electron pair repulsion theory, oftentimes pronounced as an acronym VSEPR. Now, VSEPR theory, VSEPR theory in chemistry, helps you to predict the shape that covalent molecules will take by looking at how many electron pairs exist around the central atom of the molecule. So by the end of this video, if you're given a molecular compound, you should be able to use VSEPR, VSEPR theory, to try to predict the shape that the molecule will take. So let's just jump right into this. And we'll start with an example with the least amount of electron pairs around a central atom and work up from there. So let's look at what happens when there are two pairs of electrons around a central atom. So you have two pairs of electrons around a central atom. So let's say we had the atom beryllium. Beryllium has two electrons in its valence shell. Let's say it bonded with hydrogen. So what we have now, this is kind of getting into what we're talking about here. You have two shared pairs. I just put pairs. It doesn't matter if they're shared or not, but in this case you have two shared pairs of electrons around beryllium. So there's 1, 2, and beryllium doesn't have any other valence electrons, so there are no other electrons at play here, whether they're shared or not. So basically the way that the theory works is that these shared pairs, these electron shared pairs, have the same charge. They're negative. So this shared pair is negative and this shared pair is negative. And because they're negative, they're going to repel each other. That's why it's called valence shell electron pair repulsion. And since they repel each other, they're going to try to get as far away from each other as they possibly can. Now, when you just have two shared pairs around a central atom, the farthest away that they can get from each other is if they're 180 degrees away from each other. In other words, they're straight across from each other. Now, like let's say this pair of electrons, let's say it moved this way a little bit. It got closer to this pair of electrons. Well, the like negative charges would repel, and so either this one would either move back or this one would shift over so that they're always 180 degrees from each other. And because of that repulsion, anytime you have a central atom that has two pairs of electrons around it, it forms, sorry about the phone call there, it forms what's called a straight shape. So anytime you have a central atom that has two pairs of electrons around it, those electrons are going to form what's called the straight shape and be 180 degrees from each other. Now, what you need to remember is not necessarily the angle here, but the name of the shape. So beryllium, this would be beryllium hydride, but it would be a straight molecule. It'd have hydrogen, then beryllium in the middle, and another hydrogen straight across from it. So the next example that I want to use shows how unshared electrons can kind of come into play here. So let's say I had, I don't know, let's say I had, let's do, well, I guess let's see, we'll go up to the next example, which would be if there are three pairs of electrons around a central atom. So we'll use boron. Boron has three valence electrons, and so we'll just, let's just slap some fluorines here. Okay, so we've got 1, 2, 3 shared electron pairs. So the same thing happens here. You get repulsion between the three of these. And so the way that they can get the farthest apart from each other is if they're all in a plane, if they're all flat, and if they're forming an equilateral triangle. And so you get a shape that's called trigonal planar. So anytime you have three pairs of electrons around a central atom, you're going to get the trigonal trigonal planar shape. The planar is just saying that it's flat. We're going to find out that there's another shape where there's a kind of a pyramid that's not flat, so it gets a different name. All right, so 3 pairs around it, trigonal planar. All right, so let's go to 4 pairs. We'll use methane as our example here. Whoops. There we go. Now this one's a little bit harder to kind of visualize, especially if you've never heard of this shape before. But when you have 4 pairs, it's not going to be a square, a flat square. This forms into a shape called a tetrahedron. So the adjective form of that is tetrahedral. A tetrahedron is kind of hard to draw in 3 dimensions on a flat surface, but basically it's a shape where you have all 4 of these and the carbons in the middle, and they're kind of equally distributed about the carbon. So it kind of makes this weird little, almost like pyramid-y shape, which is called a tetrahedron. It's not exactly a pyramid, it's a little bit different from it, but that's the name of the shape that you get. If you want to see any of these shapes, we can build them with the ball and stick models that we have for molecules. So let's say we've done 2 pairs, 3 pairs, 4 pairs. So now some interesting things start to happen. For example, if you have some of the pairs that are not shared, in other words, there's not an atom at the end of the electron pair, then you start to get different shapes. So let's say we have 4 pairs, but one of them is unshared. Okay, so it's 4 pairs, so it's still going to be the tetrahedral shape. But this time, there's no atom at the end of one of the pairs. There's no atom here. So you can't, it doesn't look like anything. And so what you get is kind of like, it's kind of like the tetrahedron with the top atom missing. And so what that is it's like a little pyramid. And so this is called a trigonal pyramidal shape. Now, sometimes chemists drop the trigonal from the pyramidal, and they call the planar trigonal, and then they'll just call this shape pyramidal. But if you have a question about that in a quiz, you can go ahead and ask me, and I'll go ahead and assist you with that, with the vernacular there. But the trigonal pyramidal shape is the one where there's 4 pairs of electrons, and one of them is unshared. There's no atom at the end of it. So you can still have the 4 pairs of electrons, but sometimes you get 2 unshared. This is actually a really common molecule that has this shape. I wonder if you can guess what it is. You might be thinking in your head already that you know what it is. But if I put oxygen here, I've got 1, 2 pairs, and then I have a hydrogen here and a hydrogen here. You still have the tetrahedral shape, but there's no atom here and there's no atom here. So if you can kind of vision that in your head, you get kind of like a little, it's not quite a straight line, it's bent, and that's the name of this shape. It's called bent. And so that's why whenever you see me drawing water molecules in this particular shape, some people kind of think of water molecules as kind of looking like Mickey Mouse. That's why it looks like that, because you have an unshared pair of electrons at this point in the tetrahedron, and then you have an unshared pair back here at this point in the tetrahedron, and that's why you get that bent shape like that. And then things start to get a little bit crazy. The following shapes are not very common, but they do exist, so I do want to mention them. sometimes you'll actually have more than 4 shared pairs around the central electron. So the next one that we're going to look at has 5 shared pairs, or I'm sorry, 5 pairs of electrons. And the name of this shape, I'll tell you the name before I attempt to draw it, is called trigonal bipyramidal. Bi meaning 2. And again, oftentimes chemists will drop the trigonal from this and they'll just call it bipyramidal. And so what happens is you have your central atom. For example, phosphorus might do this sometimes. And then from the central atom, you have 3 equally distributed bonds in a plane. So if you stopped there, that would just be the trigonal planar. But it doesn't stop there. There's 2 more, and one goes up at a 90-degree angle from that, and then one goes down at a 90-degree angle from that. And so what you get is you get this pyramid shape on top, if you can visualize that, and then a pyramid shape on the bottom. So it's like having 2 pyramids stacked on top of each other with their bases kind of touching, matched up. And so that's when you have 5 pairs of electrons. That's the shape that you get. And the last shape, and again this one's kind of crazy, the last shape that you're going to be responsible for this class is if there are, as you can guess, 6 pairs of electrons trying to get as far away from each other as they can. And at that point you get something that's called octahedral. And so what octahedral looks like is if you have your central atom, you have 4 atoms coming out from that at 90 degrees to each other. So this would be 90 degrees right here. Let's say that this is chlorine. And those are all in a plane with each other. And then again, you've got one coming up straight up at 90 degrees and one coming straight down at 90 degrees. So it's similar to the bipyramidal shape, except the pyramids here don't have 3 sides, they have 4 sides. See the 4 sides, 1, 2, 3, 4. So there's a pyramid there that's got four sides, and then there's a pyramid in the bottom that's got 4 sides. And it gets pretty crazy. Now, like I said, we can actually make these shapes, some of these shapes with the ball and stick wooden models that we have, but there are other things that we can use too to kind of show you what these shapes look like. You can actually buy dice in almost every single one of these crazy shapes, like octahedral and bipyramidal and things like that. And so I can show you those shapes that way too if you'd like. But those are the shapes that you're responsible for, and the way that you try to figure out which shape a molecule will have is by looking at the valence shell electron pairs. And if the pairs are shared, or sometimes if they're unshared, you're going to get the shapes that we've just talked about here. So review those shapes, make sure you're familiar with them, practice a little bit trying to figure out what shape different molecules are going to have. And if you ever have any questions, as always, feel free to ask in class. Thanks for watching.